their geometry students. So we're going to talk today about surface area of, put the title here, of cones and pyramids. It's a little bit different than the surface area of prisms, because when we talked about prisms, it was pretty much find, the area of some base, right? And then find the area of all the sides going up, and then find the area of the other base, right? That's a terrible picture. Let me draw it sideways, right? It was just pretty much, find the two ends and find the sides in between them, and no big deal, right? If it was a cube or a rectangular prism, right? It was just fronts and backs and sides and things like that. Cones and pyramids are a little bit different, and oh my God, I gotta try and draw a pyramid. This is gonna be terrible. Pyramids are a little bit different, and cones are a little bit different because they come to a point. Okay, so it's a little bit trickier to do because the sides and the top, there is no same shape on top. So pyramids won't be too bad. Cones, on the other hand, cones are going to be a little bit different, and we'll kind of cross that bridge when we come to it. Okay, so let's get right into it. Pyramids. Pyramids are pretty much the same. Cones are going to kind of be our a little bit difficult spot. So find the surface area of this triangular prism. Notice it's a triangle pyramid. I'm only going to do that 10 more times. Notice that the base is a triangle. This base is a square. It could be a square. It could be a rectangle. In this case, you need to take the area of the base, right? And to that, you need to do the area of each side. If you noticed, since these are all three, right, then the three sides, right, the three sides of this pyramid are actually all the same. So we're just going to do it once and multiply it times 3. So the area of the base, again, half the base times the height, and again, that's a area of the base, right? We sometimes will say capital B, right, is equal to 1/2 the base times the height, where lowercase b would be one of these sides right here, okay? So anyway, let's find that. The area of the base will be 1/2 of 3 times the height would be this right angle right here, 2.6. Sometimes these pictures are hard for some people to read. If you have any problems with that, it's hard for me to hand you a physical object right now because we're doing this over the computers and whatnot. But we'll see if we can find something if that's really a hard time for you, okay? And the area of each side will be 3 times what? 1/2 of the base, 3 times the height, which is 5. 3 times 5, okay? 3 times 2.6, well, I don't know that off the top of my head. Maybe you do. Doing it on my calculator, 3 times 2.6 is 7.8, and 1/2, so 7.8 divided by 2. So this is this right here when you multiply these three things, and you can drop these parentheses. It's all multiplication, 1/2 times 3 times 2.6. So if you find an even number, sometimes that's a little trick because half of an even number is usually pretty easy to take. But this would be 3.9 over here, and I know that 3 times 5 is 15, and half of that is 7.5. So it's 3 times 7.5. 3 times 7.5, which would be, that was at 22.5. Okay, and last step, let's just add those two things together. 3.9, 22.5 will be what? 26.4? 26.4 feet squared. Okay, so it's pretty much calculator work. If it helps you to draw like a little mapping, then yeah, what you're gonna do is you're gonna put your base in the middle. That's your English teacher texting me. And again, you can kind of split this up into the 3 sides about it. So if it helps you, you can label this and say this was 3, right? You can label this as 2.6. It's hard to do on the computer, but if you need to, draw yourself a little mapping. Again, here, what's the surface area? Again, I have a square base, so what are we going to say? We get the area of the base, okay? And this time, I have 4 sides, okay? So 4 times, and note that all your sides are the same. So if this was 6 and this was 5, you're going to have to do a little more work. But here, since we have a square base, again, 4 times the area of the sides, okay? So the area of the base, pretty straightforward here, is going to be 6 millimeters times 6 millimeters, length times width. plus 4 times, now the sides are triangles, so that'll be 1/2 times 6 times 9. Okay, well, 6 times 6 is 36, right? 6 times 9 is 36. I'm sorry, 6, Jesus. 6 times 9 is not 36. 6 times 9 is 54. If you want, you could do this. 1/2 times 6 is 3. 3 times 9 is 27. So your call there, whatever this is. So this is 27 inside here, and 27 times 4 is 108. Okay, and in the last step, let's just add those two things together. So that's going to be 144. Again, units, millimeters squared. Again, remember that we're taking surface area, so that's not a volume. All right, now the tricky part, the surface area of a cone. Okay, first of all, the height formula does not exist in the surface area of the cone. So first of all, what you guys should all be doing is you guys should be writing this down right here. Okay, this is the formula for the surface area of a cone. Okay, so do yourself a favor right now. I'll take a second. You can pause the video if you want. I'll stop. Write it down. Okay, let's continue. Okay, so this part, the area of a circular base of a cone is no problem, right? It's this thing. Now, in order to really derive this equation, you have to know some pretty advanced math. So if you can just plug in the numbers and take it from there, that's cool, but I'm going to explain it to you. So this first part is the area of the circle. Pi times r times s. Now, again, no height in your equation, actually, if you look real close, okay? S is going to be the slant, the lateral side. Sometimes you'll see it labeled as L, right? And if you look, it's actually the hypotenuse of the little right triangle here. Okay. Now, this cone right here, now this is a fun activity we do in class if we were there, but we're not. So let's talk about what we can do, though. First of all, things we have to notice, and I'm sorry, as you roll this out, you have to realize that this right here, this around the outside here, is actually the circumference of the circle, okay? So we'll say the circumference is equal to what? Pi times diameter. That one you should know. So this distance around here is the pi times the diameter, okay? Now, what if we took this, again, it's hard to do, this is a lot how we talked about some other shapes. What if I broke this down into little pi pieces, equal size pi pieces, right? I just kind of dice this up, right? And think about if you could make these infinitely tiny and small, right? So these are theoretically all the same size, right? And you cut them out and you reorganize them. If you cut them out and you reorganize them, you would get something that looks vaguely familiar to this. Or, you know what, let me use a parallelogram. It doesn't really matter for you guys. It would look something like this, and I'll show you how you can kind of get that. It would be a little bit bubbled on the top, but what if we reorganize those? All right, I got a long one, and I got a short one. The long one, right? Like, what if I reorganize those kind of so they made like a nasty set of teeth, right? Okay. What if I reorganize those little pie shapes here, right? Now they would be slightly rounded here, right? Maybe a little bit rounded on the top, right? But essentially, what would you have? You'd have a parallelogram, right? Okay. And again, what do we know? We know if we kind of reorganize the parallelograms, like, oh, it makes a little rectangle. If I kind of cut out this piece right here, I draw it over there, I do get kind of a rectangle. So if you cut these super duper fine, you can make a rectangle. So let's go ahead and let's redraw that as a rectangle. And again, you're assuming that you could make these kind of infinitely small, right? Something like this, right? If I just kind of kept making them smaller and smaller, you get a shape that looks something like this out of all these different parts, right? Now, what do I know? I know that since I rearrange this, kind of half of this is up here and half of it is down here. So what would I say? This is kind of, it wouldn't be pi times diameter, it would be actually half that, right? Because again, these long parts, right? half of them are up here, and half of them are down here. So I could say this is kind of like half times pi times diameter, and half times pi times diameter. Well, what's half of the diameter is the radius. So actually, each one of these is not half the pi times the diameter. It's half pi times diameter is the pi times the radius, and this is S. So believe it or not, if you kind of cut this all up, you can make it into a rectangle. It would be much more fun if we could do this in person with like party hats or something like that, but that is where this second part of the equation comes from. Regardless, you should be able to use it, okay? So again, what is this? Pi times the radius squared, so we'll say surface area of a cone. Pi times radius squared plus pi times the radius times, again, be careful, the slant or the L. Sometimes they call it L, sometimes they call it S. It's not the height, okay? If they give you the height, then you have to do the Pythagorean theorem, but that's another day. Okay, so again, this is pi. What's your radius? Well, if your diameter is 10, your radius is 5. Okay, don't square the 5 over here. Okay, so what is this? This is 25 pi plus 40 pi. Together, 25 and 40 is going to be 65 pi, and then you're going to go ahead, you're going to plug that into your calculator. So 65 pi, 65, as they say, times 3.14, because I don't like them. 65 times 3.14 is going to be 204.1, and what is that? Square inches. Okay. Okay, again, same thing here. It's the pi times the radius squared plus pi times the radius times the slant or the length. Okay, so it's pi times 5 squared plus pi times 5 times 10. Okay, remember, if they give you the diameter, take half of it, but do not take half of this one. So that's 25 pi plus 50 pi. That's 75 pi. And 75 times 3.14. 75 times 3.14 is going to be 235.5 yards squared. All right, so give the questions a try, and I will talk to you guys tomorrow. Thanks.